Hello, welcome to Season 3 of Grafana's Big Tent, the podcast all about the people, community, tools, and tech around observability. I'm here with my co-host, Tom Wilkie. Hello, Tom.
Hello, Matthew. How are you?
Pretty good, thanks. Listeners have been writing in. They'd rather you referred to me as Matt.
Do you mean listener has been writing in?
Yes. The listener's name is M@Ryer.
And it's with one T. If you're actually in my phone as Matt, quote, 1T Ryer.
Great. But then it's got two T's in it then, because you've mentioned.
Yeah, exactly. Yeah. And it's like, well, now I know you don't drink coffee either.
Yeah, cool. That's it. So did you put everyone's drink preferences in your phone?
That's their middle name.
Yeah. I like to be thorough on that. When I get someone's, like if I get someone's number, I just don't want the number. I want the company. I want the home address. Do you know what I mean? Their work email, personal email.
I had a build around recently. I'm spending the summer in London and getting all the household chores done. And he had a black tea, no sugar, no milk.
Wow.
I know, it's not a real builder.
Do you put the milk in to the cup?
No. Well, obviously, I don't just pour it into his mouth.
Yeah. Okay. Yeah. Not anymore.
I put it in after I brewed the tea, though, not before I brewed the tea.
Yeah, that's
the correct way.
Yeah. Okay. Well, we've also got guests, Tom. Speaking of a cup of tea, would you like a cup of tea, Marco?
For sure.
Welcome to the Big Tent podcast. Tell us about yourself.
Thank you. Hello, everyone. I'm Marco. I'm a software engineer at Grafana Labs. I joined Grafana 5.5 years ago, quite a long time. I've always worked on our metrics product, and I spent the last couple of years leading the new Mimir architecture project.
We're going to learn more about that today. We're also joined by Cyril Tovena. Hello, Cyril.
Hey, Matt. Hey, guys. I'm Cyril, so I've been working at Grafana Labs for like 6 years now, and I just recently moved to the AI department, but I was working on Wilkie, so touching on also database at Grafana Labs before.
This is not a competition for how long have we been working at Grafana Labs, folks, because I have been here over 7 years now.
Right, it's not a competition, though, you say, Tom, but if it was,
if it
were. Yeah, okay, so cool. But just to be clear, it's not. I also work with Cyril quite a lot on the assistant and various other sort of agentic LLM things, which is very cool. So he's a friend of mine now, I'd say. Would you say that, Cyril? Or we'll see.
Yeah. Except
put him on the spot, Matt.
Yeah. I was like, wow. Except when I use 2T in my text. When I say
yeah, still. Well, after years, still doing it.
Yeah. It's fun.
It's fun. And from WarpStream, we're also joined by Ryan Worl. Hello, Ryan. Welcome. Tell us about yourself.
Hi, thanks for having me, Matt. I'm Ryan Worl. I'm one of the co-founders of WarpStream. And after the acquisition by Confluent last year, I'm a director of engineering at Confluent now. Previously, slightly relevant to this podcast, I worked at Datadog. Boo.
No, Datadog's not a dirty word here. And I guess Ryan, leading the witness a little bit here, but how long have you been working with Grafana Labs?
Oh wow, I think it's over a year now, probably at least 15 months. Something like that.
So. Was it safe to say we were one of your first, if not the first customer?
I think you were first three.
First three. Okay.
Yeah, it may have been number 2 or number 3. I can't remember. Definitely bigger than the other two. But yes.
Well, we'll get onto that, I guess, won't we? But today we're going to talk. So Marco kind of alluded to it in his intro that he's been working on a new architecture for Mimir, and all of us say Mimir wrong. I do apologize for the rename on the project, but I say Mimir. But yeah, Marco, what is this new architecture and what is it called?
Well, internally we call this project Sigyn.
Sigyn.
But at the end is just the next generation architecture of Mimir. And all the development of the new architecture is done in public. So Grafana Mimir is an open source project, will continue to be open source. And the new architecture is supported in open source as well.
Nice.
Sigyn is a goddess in Norse mythology.
North mythology, yeah. As opposed to South mythology.
Yeah, it's like from the north, like mythology, like from Manchester. Sigyn is a goddess in Norse mythology, primarily known as the loyal wife of Loki. Is that right? And what happens if when we run out of Norse gods? Do we have to just stop making
This is why
products?
we chose the the Norse and those kind of pantheons of gods, because there's a lot of them, right? So we
Nice.
don't really have to worry about running out. I
Yeah,
really
that's what-
I really wanted to call Mimir Mjolnir though, like
yeah.
Thor's hammer, but no one could pronounce it. Even fewer people than can pronounce Mimir. So before we talk about Sigyn, like let's talk a little bit about Mimir and the Mimir project and a little bit of the history, like really shortly, like and what is Mimir, Marco, like, and why are we talking about it?
Yeah. So Mimir is an open source time series database. It's horizontally scalable, multi-tenant, natively support OpenTelemetry metrics and Prometheus metrics. Mimir has been designed to store massive volume of metrics in a reliable and cost-effective way. And today, it's what it powers the hosted metric solution at Grafana Cloud, other than plenty of users using our open source version.
And just to give some perspective on like the scale of Mimir now, like it's doing, I think, like billions of active series, right, across it just in Grafana Cloud. And if we talk about all of the customers of Grafana Cloud that we know in the open source usage of Grafana Cloud, then it's easily doing tens of billions of active series worldwide. So I think it's probably one of the biggest hosted Prometheus like projects out there now in terms of scale, which is nice. But like, we or I guess, because spoiler alert, I started Cortex, which is the project that became Mimir, made some architectural decisions 10 years ago when we started this project. That I think, Marco, you've spent your last 5 years fixing, shall we say? Is that accurate?
That's really fixing. I see everything as an evolution. The market change, the context change, the technology change, and so we change our products as well. What we build is not static; is more dynamic, and just follow the evolution like everything. I'm used to say that I just did the re-architectures since when I joined Grafana Labs. First we changed the storage engine, and we moved from a database like Bigtable to the object storage back in time. That's something we did originally in Cortex. And I spent the last couple of years with the second big re-architecture of Mimir, which I guess is what we're going to talk about in the rest of this podcast.
And just again, I know I'm kind of really stringing out this intro here, but just to set the scene, right? So Mimir, the original architecture, or kind of the second architecture, not the third one. This was inspired heavily by Cassandra, right? So it did replication factor 3. It did
Quorum 2.
Quorum reads and writes. It offloaded everything to object storage eventually. But in the meantime, we had this big kind of tier of services that we call ingesters that stored everything 3 times for reliability and obviously sharded things for scalability. Yeah.
And ingesters had a write-ahead log to replay the data, the most recent data that has not been uploaded to the object storage yet, in case of restarts, of crashes or so.
And the thing, I guess, spoiler alert, the thing we're trying to fix or have fixed in the Sigyn re-architecture is this replication cost a bunch of money, right? It cost us money to store this data 3 times.
Yeah.
It used a lot of local storage for this write-ahead log. The chatter between all the services on the network meant it was expensive in network costs, right? All of these things were really holding us back from kind of really achieving massive scale, economically, if not technically.
Yeah, that's absolutely correct. Replication factor 3 is expensive. On the ingestion path, what we call the write path, we have to keep 3 copies of each data. And when we query back the most recent data from the ingesters, we have to query at least 2 copies in order to guarantee consistency. But it's, I think that there's more than just cost reduction. It's also about reliability. In what I now call the old architecture, ingesters are also the weak link between the read path and the write path. The typical issue we have is some heavy queries issued by customers that overload the ingesters. And if ingesters are overloaded, the ingestion path, the write path, is affected as well. So we may fail to ingest new metrics we may have, in the worst case scenario, we may also have an outage affecting both the write path and the read path at the same time.
Yeah, the ingesters are a big distributed single point of failure, big distributed replicated single point of failure in the old Mimir architecture, I guess.
Also, the way the sharding and the replication works in the old architecture makes the ingesters fragile when it comes to computing the quorum. Essentially, you just need 2 random ingesters to be unavailable at the same time.
Oh yeah, good point.
To have an outage, which is something we wanted to address with the new architecture as well. So actually, I think we can summarize the 3 big goals of the new architecture as decoupling the read and the write path. I'm used to say that whatever's happened on the read path should not affect the write path, and vice versa. We would like to have a better resiliency on node failures. We will dive more into this later, but the core idea of the new architecture is to have a predictable partitioning scheme, so that if one node is unavailable, we know exactly to which other node to go to query the same exact data of the unavailable node. And last but not the least, reduced costs of running the Mimir infrastructure. So reducing the Mimir TCO. And one of the biggest cost reduction comes from the reduced replication factor and quorum in the new architecture. We don't have replication factor 3 and quorum 2 anymore.
Yeah, so when you do these big kind of redesigns, is this something where you literally do it in docs? You sit down and just have to think through basically all of this at the same time? Or do you try and kind of break it into bits which you can kind of specialize in? And can you do it iteratively and stuff? How does it work?
My personal approach is to always start with a prototype to validate the idea. The prototype should be, a quick hack. I think about prototypes like hackathons, something you should get done in a week. But in a week, you should get something working. Very hacky, but at least to prove the idea. Then, to me, it's the right time to go back to paper, write down a doc with the high-level design of the system you want to build. Describe the problem you want to solve and how you plan to solve this problem. And then there's the implementation phase, or what I call the productionizing phase. If it takes 1 week to build a prototype, it probably takes 1 year to productionize it. And that's where I typically try to break down this big work into smaller deliverables, something that we can iteratively build and roll out to production. My main goal typically is just to validate our assumptions and our ideas as soon as possible. I just don't want to spend a year building a new piece of software and then realize that it doesn't work because we haven't considered something.
Yeah.
We should continuously validate our assumptions.
Yeah, I love that.
I remember this distinctly, like when this happened, by the way, because we were working on adaptive metrics at the time. This was like almost 2.5 years ago when we first started this. We were working on adaptive metrics. This is the idea that we can aggregate metrics before we write them to disk. And the whole idea was the aggregator had to be cheaper than writing them to disk. Right. And we were actually struggling to do that. Right. Like the aggregating metrics before writing them turned out to be more expensive. And one of the engineers not here, had the idea, let's use Kafka, so we don't have to do a lot of the quorum consistency and the replication. And let's just put everything in Kafka and then write these really lightweight aggregators, and a very, very different model to how we were architecting things. And it turned out to be more cost effective. And we started to get used to running these big old open source Kafka clusters with all their local disks and all the things that come with that. And honestly, we couldn't have timed it better, because about the same time, this project popped up on Hacker News, right? And you were number one on Hacker News for a while, weren't you, Ryan? And it was WarpStream was pitched as Kafka, but on object storage.
Correct. Yeah, we were on the front page of Hacker News with our initial launch blog post for, I think it was like a day and a half. The response was mixed, I would say, for sure. There's a lot of skepticism, but I'm glad the timing worked out for you.
I mean, the response internally was none of us particularly liked the operational aspects of Kafka, but we definitely liked we're beginning to understand and admire the architectural implications, I think, of Kafka. And so the fact that, I mean, for us, it really is. We just don't like running local disks. Like, it's just a pain, I think. Like, so the fact that the project popped up at about the exact right moment for us was like so serendipitous. And then I think, like, I remember, like, Marco, you and I had a chat about, like, should we learn from adaptive metrics and re-architect the whole of Mimir around this concept? And obviously, Marco, you kind of took that and ran with it for a few more years. Is my retelling of history just like rose-colored glasses, or is that actually kind of semi-accurate?
No, it's accurate. It's definitely accurate. Speaking about Kafka, I always try to distinguish between the Kafka protocol and Kafka the software. I think Kafka the protocol is great. I think Kafka the software is quite hard to operate at scale. And that's where, for us, WarpStream was some fresh air. Because it coupled what I think is a good protocol with an easy to operate implementation,
and not just easy to operate as well. I mean, we as an organization at Grafana Labs, we don't actually run a lot of JVM based services, right? Like it's not an area of expertise we have. I think a lot of the challenges we have with operating Kafka come from the fact we don't have the expertise in operating the JVM at scale, right? And Ryan, WarpStream's not JVM, right?
No, WarpStream is all written in Go. That was one of our goals as well, was to make the operations that like down to the level of, I don't need to understand like how to make a fancy clustered thing run, all the way down to like the installation process on the single machine. It was designed to be as easy as possible, and Go definitely makes that possible. I think the JVM definitely is better than it was, say, 5 years ago in terms of how easy it is to operate. But yeah, it's still scary for a lot of organizations that don't have somebody who, understands deeply how the JVM works. And a lot of times it's not worth hiring those. Yeah. If you didn't already have a need for, somebody that was like running Cassandra for you or something like that, just.
I also think like a lot of people, myself included, are carrying scars from 15 years ago using the JVM. And obviously it's a lot better now than it was then. But yeah, I just like when I was back in the Cassandra days, like, yeah, I could not wait to get away to a compiled language. Go came along, which was nice. So I guess so Marco, what are we, what is the Sigyn architecture? How has it changed? And I guess we've spoilt it now by talking about Kafka, but like what are we doing and how is it different from the old Mimir architecture?
Yeah, well, guess what? We introduced Kafka in the big picture. The main idea of the new architecture is to put Kafka between the write path and the read path. Essentially, write path request, so a request to ingest metrics, complete as soon as the data has been committed to Kafka. And then this data is asynchronously replayed by ingesters. Ingesters in the new architecture are just read path components, pure read path components that are used to serve the most recent data to queries. So the core of the idea is to put Kafka between the write path and the read path and leverage on the guarantees that the Kafka protocol give us. For example, full consistency on a given partition. Like the main, one of the core differences between the old architecture and the new architecture is that ingesters consume from partitions. And when they consume from partition, the consumption is gapless. If you restart an ingester and the process is down for 5 minutes, at startup, it will resume consuming from where it was left. There are no gaps in the data, which is very different from the whole architecture. This allowed us to have just quorum 1 on the read path. We just need to query each partition once. We don't have to query 2 copies of each data because there may be gaps in one of these 2 copies, like in the old architecture. We still have a replication on the ingesters for high availability. But instead of having a replication factor 3 in the ingesters, we have replication factor 2. So we have 2 copies of each data and we just query one of these copies. So again, we have replication factor 2, just in case one of these ingesters or some of these ingesters becomes unhealthy or restart or whatever. We still have another copy of the partition. That's the gist of the new architecture. Obviously, there are nuances in this architecture. There are some trade-offs we picked, but the core difference is this one: having Kafka in between and a different partitioning and replication scheme.
And one of the things, again, like a lot of things happened around this time, because I remember, Grafana Cloud was predominantly deployed on Google, 2 years ago, and we started to see a lot more demand from customers and partners for deployments of Grafana Cloud on Amazon, right? So I remember around the same time we started spinning up regions on Amazon. I think we've now got like 50 of these regions, like not just on Amazon but across a bunch of providers. And it's interesting, right? Because in the Google world, we used to deploy everything in just a single availability zone. Because our observation of Google's kind of zonal and regional reliability is that they're basically the same thing, right? If and I don't really speak ill of Google here, but if there's a lot of region global services that go down, and then it doesn't matter if you split your application across multiple zones. But we found in Amazon that was not the case, right? We found when we started deploying in Amazon that we really had to go multi-AZ, because their zonal availability was worse than their regional availability, and their regional availability was probably better than Google's regional availability. Again, not sponsored. And so we had to kind of battle then with a lot of the increased network costs, didn't we?
That's right. The main downside of going multi-AZ is that if you do a bunch of cross-AZ data transfer, your TCO will increase significantly. Both in GCP and AWS, you pay for cross-AZ data transfer, and essentially you pay 2 cents per giga to transfer from one AZ to another AZ. And that's when we started to look at WarpStream. So if you run the new architecture on top of Kafka, you will still pay for cross-AZ data transfer to replicate the data between AZs. The key changer, the game changer for us was WarpStream, adopting WarpStream.
Well, how does WarpStream help with the inter-AZ traffic, Ryan?
So the way that WarpStream solves the cross-AZ data transfer problem is, instead of replicating, and Kafka, the open source Kafka project works, roughly the way Mimir did in the second generation architecture, where it's replicating from, it's not like a quorum consistency. It's like, looks a little bit more like Raft, where there's a leader and then it's, replicating to followers, but high level idea is the same, where you're replicating from, the write coming in one availability zone, and it's being replicated to the followers in 2 other zones if you're running in a 3AZ setup. The way that WarpStream differs is that instead of replicating over the network directly between nodes, WarpStream writes data directly to object storage first. So we receive a bunch of concurrent writes from different clients, batch those writes together, and then write a file to object storage. And in AWS and GCP, basically everywhere that there is object storage, the guarantees are that the data is replicated across the same number, some number of availability zones that would be equivalent to 3. The data is replicated, and you can read it out from any of those other zones and not pay any cross-AZ data transfer costs. So by kind of using object storage as both the storage layer and the network layer, you can bypass the cross-AZ data transfer costs in exchange for accepting the latency penalty that comes with writing the data to object storage first.
It sounds almost like a loophole in Amazon's billing model. Like, how does Amazon feel about this? Have you had any interesting conversations with them?
So no, I haven't had any conversations with Amazon. You're not the first person to bring that up, and basically there's a long line of companies whose products take advantage of this loophole, quote unquote. Like the biggest and most obvious one is probably Snowflake, and that Snowflake has been using a very similar model to this for, well over a decade at this point. And it's just like this assumption is just so strongly baked in that it's kind of impossible to take it back without upsetting, some huge slice of their customers. Yeah, it would be really challenging. And then also the competitive dynamics between the major CSPs, I don't think would let it happen.
And it's the same, we talked about S3 and Amazon, but the same is true on other CSPs.
Yeah. There's the only major CSP that is different in this respect is Azure, and that they just don't charge for cross-AZ data transfer at all. They said that they would for a long time, and it was on the pricing page, but never actually happened.
And they recently publicly announced that they will not.
Yeah, they did finally acknowledge that they weren't going to.
It's like Google for a long time never charged for Prometheus queries, for Google managed Prometheus. I don't know whether they do now or not, but they didn't for a very long time.
Well, AWS just started to apply the pricing for some load balancer networking cost in May 2025. I recently discovered. Yeah.
Oh, is that what
it was discovered? Something in the pricing page since ever, but it was not actually built.
Oh, interesting. That explains a few things. Marco and I have been working a lot on our cloud bills this past few weeks, so we've been deep in the Cost Explorer.
I do have a question for you, Ryan. I'm wondering, what's the catch? It sounds like WarpStream is solving a lot of our issues, but it's like any software. There's probably trade-offs. So what's the trade-off in WarpStream? How does that work?
Yeah, the biggest trade-off is basically end-to-end latency and produce latency. So those are two distinct components, because I like to break them down differently and I kind of explain where the latency comes from. So obviously writing data to object storage is much slower than writing to, say, like a local NVMe SSD. That part is really obvious. The primary cause of latency in WarpStream, though, is actually the batching that you have to do in order to make it cost effective. So instead of writing, we could, if you had some straw man where you wanted to write just one record into one object in object storage, obviously you'd get no cost savings because every write to object storage is fairly expensive. But if you instead batch a bunch of records together and then write them all into one object, as the size of the object grows, you get to amortize the cost of that put over more and more bytes. So the effective cost per byte goes down. And the knob that you have to tune the infrastructure cost in WarpStream is basically how long do I wait before I write that data to object storage. So we can kind of tune the produce latency up and down based on what costs you're willing to absorb. And now there's also, different tiers of object storage, like there's S3 Express One Zone in AWS, and Azure Blob Storage has a premium tier that is lower latency. There's the storage cost is higher on those tiers, but the latency to write is lower. But it still costs something to do that initial put, and you still have to play this game of tuning. How long do I want to wait? So that's the produce side. The end-to-end latency is also higher because we're batching this. We're batching the same way on the other end. We're basically doing the same process in reverse to read the data out. But on the read side, there's a little bit more flexibility because you can cache the reads from object storage, because the objects are immutable, you can cache them. So if you get subsequent reads from, concurrent readers of the same partition, or, getting a little too in the weeds of how WarpStream storage engine works for now. But basically it's all about waiting. How much are you willing to wait in order to achieve a certain cost threshold? Obviously, you're taking a little bit of a risk on a new implementation of something being perfectly compatible. It's like every new Postgres compatible database that comes out has its own little quirks. But basically the big one there is the latency.
Yeah, I found that interesting because in the previous company I was working at, they were using Kafka for event system. If something is happening in the system, they will create an event, and then at some point it will go into something like an ETL or a database or whatever. And the latency was never really something that was required. But ultimately what was required is more being able to just put something somewhere and it will be there and I will be able to consume it at some point. So I'm wondering, do you think that like the biggest majority of Kafka user actually will fit into I don't care much about the latency? Or do you think like it's actually a lot more people needs the latency constraint on Kafka?
Yeah. In terms of byte volume and infrastructure spend, it's by far the non-latency sensitive use cases. In terms of business value or in terms of pure customer count, I think it's a much less clear. So the way that we found our introduction into the market basically was trying to target these latency insensitive use cases where, it's like logging, metrics, some kinds of CDC workloads where the latency doesn't really matter. You just want, the cost to be as low as possible and the operational burden to be as low as possible. And we're letting other, with WarpStream being part of Confluent now, there's a whole suite of other Kafka things at Confluent that can be used to accomplish the rest of the spectrum of use cases. And then, WarpStream is also the BYOC model of how we deliver it is also a little different.
For our listeners, Ryan, what's BYOC?
Yeah, BYOC
and for Matt as well, obviously.
BYOC stands for Bring Your Own Cloud. So
cloud. Yeah, I was going to say I don't need to bring one of them, Tom.
The idea is basically that there's some software that you want to run from a vendor and you would like it to ideally run inside your own VPC, inside, on hardware that you're in control of because maybe you're processing sensitive data and you have compliance restrictions about what you can do with it, or you have really good discounts with your cloud provider and the infrastructure cost would be lower if you ran it compared to, just running it in an AWS account with no discounts or whatever the vendor is willing to give you. There's a lot of different reasons why people like BYOC, but basically the way that we deliver WarpStream is you get a Docker container, we have a Helm chart, you run it in Kubernetes on your own Kubernetes cluster in your VPC, and we don't have any access to the actual raw data flowing through the cluster. So it lets you kind of sidestep a lot of annoying compliance burden if you were to use a vendor that didn't have, compliance certificate list a mile long. Confluent has a lot of them, so they're very effective. But if you're looking outside of Kafka, just at other infrastructure providers, it's there's a lot of people out there that will run different infrastructure pieces of software for you, but will it fit with your compliance regime is a much harder question to answer, especially if you're in a regulated industry like healthcare or financial services.
So I guess one of the things I'm interested here, you talked about volume and, latency being, the less latency sensitive applications being the higher volume ones. Marco, do you happen to know off the top of your head what our volume is going through WarpStream? Because we've moved a lot of workloads to it now, haven't we?
I'd love to know this too.
Yeah, come on. We can say. Marco, are you loading a dashboard right now?
No, I know on top of my mind. These are numbers I look at every day. Our largest installations are currently producing 20 gigabyte per second uncompressed for a single WarpStream cluster. And since, as I mentioned before, we have replication factor 2, we consume the double. So we consume 40 gigabyte per second uncompressed. We are using snappy compression and our data is not super compressible. So the compressed data transfer is not much lower. It's about 7-8 gigabyte per second produced compressed. That's funny because when we started prototyping the new architecture and we approached WarpStream, we benchmarked WarpStream at 1 gigabyte per second uncompressed, and we thought that was a big number. And now in production in a single cluster, we are doing more than 20x that time.
I love that you're quoting a single cluster, a single big cluster. But I was looking.
Yeah, that's very important.
Aggregate across all of our clusters, right?
Yeah, that's not an aggregate across all clusters. It's like Mimir. When you talk about 1 billion series, it's not 1 billion series across 10 different clusters. It's in a single cluster.
Yeah.
To me, that's what makes the big difference when it comes to the scalability. Because you have some unit of data, like per tenant data, that you can't really shard between different clusters. So that's why I think per cluster numbers matter more than the aggregate across all the clusters.
Yeah, I was just looking for that big vanity metric, though.
Yeah, I was going to say that's the real fun one for me. Is like I can go quote this podcast and say so much data.
Have we exceeded? We must have exceeded 100 gigasecond now in aggregate.
Yeah, for sure.
Yeah.
Okay.
So, and where does I guess, Ryan, where does that put you amongst all of the WarpStream? Where does that put us amongst all of the WarpStream users?
Oh, that's a good question. So I don't think I can say precisely, but you are definitely in the upper percentiles. That's for sure.
Very diplomatic.
Yeah. In terms of the amount of traffic in one cluster, you're about parity with our biggest other customers. Yeah.
Challenge accepted.
Yeah. Keep going.
Well, we will. Yeah, we will. We've got some.
We just have to write less efficient code.
Oh, that's easy. That's the easy one. Yeah. No, we've got some big customers coming up pretty soon, so I think we'll be pushing those limits pretty soon. And how? I mean, Marco, like you've been using WarpStream now for over a year. How has it been? Like, is it delivered on everything that Ryan promised?
Pretty much. Working with WarpStream people was great. Along the road, we naturally had some issues here and there, like some performance issues or scalability issues. But at the end, the support we got from WarpStream was great. So to get back to your question, operating WarpStream is fairly easy. In particular, operating the agents is very, very easy. Agents are stateless. I personally consider the agents the dumb part of the system. The system essentially is divided into two big blocks: the agents on one side and the WarpStream control plane on the other side. So operating the agents is very straightforward. They are stateless, easy to horizontally scale. The load is evenly distributed between the replicas. I think we never had a single issue caused by the agents. Over the time, with our scale growing, we've hit some performance or scalability issues more on the control plane side. And that's where we got a lot of support from WarpStream. They both provided short-term workarounds and long-term fixes and improvements. I personally think that, a year and a half ago, when we benchmarked WarpStream at 1 gigabyte per second, I correct me if I'm wrong, Ryan, but I don't think that at that time it would have succeeded at 20 gigabyte per second. It was more, a natural growth supported by continuous improvements from the WarpStream team. And
we've also seen the inter-AZ costs and not be there and like it behave the way we expect.
Yeah, there's still some cross-AZ data transfer, both on Mimir side. We also have a control plane, and on WarpStream side, they also have a control plane. But that's a 0.something% compared to the data plane. The bulk of the data transfer is the actual data plane. The control plane data transfer is minimal and not significantly impacting the TCO. What's actually impacting the TCO a lot is the S3 cost or the object storage cost. If we look at the WarpStream TCO, for us, 50% of the TCO is S3 or the object storage in other cloud providers, and 50% is everything else, like the CPU, the memory, the data transfer, and.
And how much of that is the CloudTrail events?
I can't speak about it.
Well, for the listeners, we, as I mentioned, Marco and I have been doing a lot of work on our cloud costs, and one of our engineers found hundreds of thousands of dollars a month worth of CloudTrail events that we'd gone unnoticed. But no, it was quite easy to turn them off, so we can't blame WarpStream for that.
Yeah, If you run anything on top of S3 that does a lot of operations and you have Cloud Trail enabled for S3 events, be aware of the growing build.
And have we also seen has WarpStream and the new Sigyn Kafka architecture, allowed us to scale Mimir to bigger tenants? Is it delivered on the kind of cost savings in a global sense? Is it delivered on the reliability improvements that we talked about at the beginning?
A lot of questions in a single question.
I'm a terrible interviewer.
No, you're great. Well, let me start from this one. Are we saying cost reduction saving? Yes, absolutely. We did. Should we share some percentage numbers, or should we skip it?
Yeah, I think you can. Don't give away the absolute TCOs, but the percentage improvements we've seen for sure.
In Grafana Cloud, we reduced the Mimir TCO by 25%, moving from the old architecture to the new architecture. And it's fair to say that we started from a position where we squeezed the TCO down as much as possible in the old architecture. So we started from a position where we optimized everything that came to our mind. And to further optimize TCO, we thought that it was required to re-architect part of the system. What's about scalability improvements? I wouldn't say that the new architecture is more scalable than the old one, just because the old one, I consider the old one very scalable as well. I think even with the old architecture, we reached a point where there's nearly no size that scares us too much.
I'm going to quote you on that, Marco. When a customer asks for 10 billion active series, that Marco says we can do that now, yeah?
Well, you can do it at a cost. There's always a cost. I think we it's fair to say that we got some knobs. Like we recently introduced support for cross-cluster federation. So we are now able to shard the tenants even between different clusters. I feel quite comfortable saying that now we have options both in the old architecture and in the new architecture to support our most demanding customers. I think it's more interesting the question about reliability, because that's where we got measurable improvements compared to the old architecture. Mostly thanks to the decoupling between the read and the write path and the different partitioning scheme, as I mentioned before. Now, this is harder to measure, but it's fair to say that we over the last year we've seen some issues affecting only one of the two paths, like just the write path or just the read path. There are more common issues on the read path, like performance issues caused by heavy queries, but not affecting the write path anymore.
Nice.
With the old architecture, the write path would have been affected, and in the worst case scenario, you could have a full outage both on the write path and the read path. In the new architecture, we also had a couple of bad outages on the read path. But the write path was just, continuing ingesting metrics as usual.
And I guess now, because you're consuming from Kafka for the read path, you can scale, you can read or consume multiple times to scale the reads now. I guess you didn't have that possibility before.
We didn't have that possibility before. Yeah. In the new architecture, there's also a new component that I didn't mention. It's called block builder. And it's responsible to periodically consume from Kafka or WarpStream and build the TSDB blocks uploaded to the object storage for the long-term storage. Previously, it was the responsibility of the ingesters to build these blocks, but now we delegated this responsibility to a new component. And that's yet another component that we can horizontally scale. If there's an high load on the write path, we can just scale out the block builders and build smaller but faster blocks.
Nice. Very cool.
In the old architecture, when they ingest, since the data is replicated 3 times, when the ingesters upload the blocks to the object storage, these blocks contains duplicated data, and specifically contains 3 times duplicated data. In the new architecture, the block builder consumes from Kafka partitions and in Kafka partition, data is not replicated. So we consume each data point just once. And when we upload the blocks to the object storage, they are already deduplicated. We still have compactors to compact horizontally sharded blocks, essentially blocks sharded by time. So you have, instead of having a lot of 1 hour blocks, over the time 1 hour blocks are compacted into 2 hour blocks, and then 6 hour blocks, 12 hours, 24 hours blocks, and so on. But the compactor does not deduplicate metrics anymore in the new architecture, because we don't have duplicated data in the object storage in the first place.
So the compactors got cheaper to run as well then?
Compactors were already cheap, so I wouldn't claim that a significant TCO reduction comes from compactors, but yeah, they are slightly cheaper.
Nice, very cool. And I guess we like this so much that we've rolled it out to everything in Grafana Labs, right? So, and now we get to the reason why Cyril's here. We're doing this in Loki, right, Cyril?
We're doing this in Loki, we're doing this in Tempo. I think we're looking at doing, I don't know if we're doing it in Periscope, but I wanted to touch on something that I think is very interesting that we haven't talked about yet, is that for Loki, it's a bit different. It wasn't specifically just about TCO, it was about innovation. I think it's quite hard to actually innovate when you have a replication factor free, because if you want to create a new index, then, where do you create that index? It's kind of hard to do that. So I think it's nice to be able to decouple or consume, as you want the data, so you can build an index on the side, and something that wasn't possible. Another example is maybe adaptive logs or adaptive telemetry that we have now. I think it fits very well, like being able to have another set of pods that ingest the same data but for a different purpose. That's definitively nice.
Of course, the original adaptive metrics team recently moved over to using WarpStream instead of the open source Kafka as well. So yeah, that's another bonus.
Yeah, and the adaptive logs are also super excited about this. Yeah, and they are also doing the same. Yeah.
And how far? I guess we talked about this as if Sigyn's done and dusted. Like, what have we got left to do? How many clusters and tenants have we got left to migrate? Like, what does the future hold?
Right now, about 60-65% of our customers are already running on the new matrix architecture. And the plan is to move 100% of the customers by the end of the year.
And where are we at with Loki? I think we call it Thor, do we, in Loki, Cyril?
We call it Thor. I think we are probably a bit behind because Marco started this, so we're following, and it's like we have a lag of 6 months, if not more. But we are already in production. There's like 5 cells that are running in production. So like every new cell that we create in Loki are using WarpStream by default. But changing other cells takes more time. And I think this is something we haven't touched on, but like all the work that Marco did is on the flying engine. Like it's definitively difficult to change, the ingestion from replication factor free to WarpStream as we are ingesting billions of metrics. So this is a difficult task for sure.
The flying engine is the swapping the engines on a plane mid-flight.
Right. Yeah.
Okay. Good.
I prefer that though. I prefer flying engine.
Yeah, we're just going to say the flying engine. Yeah.
This is going to be the quote.
Yeah, that's the poster now. But the thing is, I can't imagine working on something that takes a year. I can't really sort of fathom that.
Well, Marco's been working on Mimir for 5 years.
Have you tried using Cursor? Marco, just type in, use WarpStream, make this faster.
I'm using Claude code instead of Cursor. Because I actually love my IDE, which I use Golang, and I'm very stick to Golang. Right. Mm-hmm. So I found Claude code very interesting because you can use the LLM on the terminal while using your IDE without having to learn a new IDE. So I'm using Claude code nowadays. I love it. I think it's typically smarter than me, especially on small piece of softwares. It's still quite difficult to use it for Mimir itself. The code base is very complicated. It's huge. It's lacking a bunch of context. But over the past few days, for example, I've built a tool for some internal networking analysis. I 100% built the tool with Claude. I didn't write a single line of code. I just typed what I wanted. I guided Claude step by step. Like I told him, build this component should work this way and so on. I didn't ask for the final result. And I just spent days telling Claude what to do. But for these kind of tasks, I think it's very good.
Nice.
And speaking about Warp, I'm now using a terminal called Warp, not WarpStream, but Warp.
Yes, I use that. That's very good if you have to do GitHub merges and stuff. It'll do the thing for you. It'll resolve it, and you can kind of tell it, prefer this. It can choose the content as it's merging, so you can tell it in advance. Prefer the more complicated prompts or something, and
It's also really good for finding things on your network. You know how you need to know the IP address of some random device.
Oh yeah.
If you just ask it, it finds it. Like, it just uses all the tools to figure out. Like, Ryan, how do you feel that there's now a new shinier warp on the agenda?
I actually think it's older.
Oh, is it?
I think it is. Yeah. So we must have we previously had a different project, my co-founder and I, called Warp Table.
Okay.
And I think that might predate Warp, the terminal. So I guess I don't know who's really there first, but.
Are you using Claude Code or Cursor or Warp on internally? Yeah.
So we're big Cursor folks on the WarpStream team. Cursor is actually a customer of WarpStream.
Oh, nice! Congratulations.
Which is very exciting. They're super fun to work with. I've had a pretty good experience using Cursor. I tried kind of the same strategy that Marco was describing, where it's not great at a really big, complicated code base, just asking it to do arbitrary things. But if you can kind of scope a very narrow problem for it, like writing a Go package, for example.
Yeah.
If you can ask it to write just one package and then you glue everything together yourself, or it's very obvious at the end how to glue the things together, and you ask Cursor to do it, then it can be, the success rate is pretty high. But just asking it to do some arbitrary thing in a giant, 500,000 line code base is not going to work well.
Yeah, the higher level stuff, the harder it is. There's more option for it to sort of get creative or just misunderstand. Whereas if you build small little focused bits, it does a surprisingly good job. And then, like you say, you stitch them together to create the whole. So you're kind of still doing the engineering.
Are you justifying your salary here, Matt?
It's like, it is, honestly, sometimes I will just vibe it if it's UI stuff and it's essentially just tweaking CSS.
Most of the time, Matt.
Then I'll vibe that. I mean, you should see some of the new stuff we've built, though. You wouldn't mind. Yeah, you'll see it.
I think we're, Ryan, was there anything we should have asked you that we didn't?
I think that what I'd be interested to learn a little bit more about is like, what's the, how has using WarpStream changed the way you're thinking about new features? And has it opened up any possibilities? I mean, Cyril, you kind of alluded to it a little bit, but like, what are the things that things that were on the to-do list of, what if we had an infinite amount of time to do this new big feature, but now maybe it's a little easier that you have the ability to reconsume the data multiple times?
Yeah, I think so. I'll answer from my side. I think Marco, you probably have another answer. But for the Loki folks, it's definitively around being able to build another storage on the side while the current storage is still working. So that's kind of nice because you can experiment. So that what has changed, I think, in the culture of the team, like being able to experiment on the side by building another storage or maybe multiple storage and see which one works the best. So yeah. Those kind of experiment wasn't really possible before.
It's very common when people are building technology not to really think about that. But this, like you say, Cyril, this flexibility, we try and do it. We'll try and make choices that gives our future selves the most options, because we assume we don't really know. We have a strong feeling about things, but you don't really know, and often we're wrong. And pivoting is kind of, especially where we're working in AI stuff, like there's new things every week to sort of pay attention to. I think that's a good lesson for anyone building systems, really, is that remember that probably, especially if it's a platform, you've got engineers that could be working on it and building things. How do you enable them? And
I'm not surprised that Cursor and Grafana Labs are using WarpStream. I think it's right now. It's probably the best technology for ingesting data if you don't care that much about the latency. So I think it makes all sense to me.
Marco, what's on your agenda for, what has WarpStream unlocked for you?
For sure, it allowed us to build the new architecture faster. If we would have had to rebuild a WarpStream-like solution in Mimir itself from scratch, it would have taken another year. So for sure, it was about delivery and speed and velocity. To answer Ryan's question, a use case we recently had and we immediately thought about WarpStream was a state synchronization or state propagation in Mimir. So far for the control plane, we always use the member list. It's a gossip-like protocol, which is great as far as you don't need a huge data transfer, and you are fine with just the in-memory propagated state with no persistence. But we recently had another use case for a new service we are building, where we immediately thought about WarpStream and we started building it around WarpStream to propagate state changes between replicas. Tom, you didn't ask me if there's any question I wanted to.
No, you were next. I haven't got to you yet.
Okay,
Cyril.
cool.
Oh no.
Sorry, no, Marco. What should I have asked you? What should Matt and I have asked you?
You didn't ask me if I could go back in time, if I would make the same decisions.
Oh, well, okay. Would you?
How long do we have?
Well, I have another call to go to.
It depends if you can go back in time or not.
Yeah.
Can we go back in time?
What would you do differently?
The new architecture, yes. WarpStream, absolutely yes. Actually, for us, the pain point was and still is the higher produced latency. We knew since day zero, but we underestimated the impact on some agents used by clients to remote write metrics. We were coming from a Prometheus background, and Prometheus or Grafana Labs, they have dynamic concurrency. They have no troubles handling an higher latency. But we learned the hard way that some customers are, legitimately using other type of agents that are much more problematic when the latency, the write latency increase. What I regret the most was not seeing this problem 2 years ago, because if I did, I would have probably invested more time improving these agents while working on the new architecture as well. Now it's a bit late. We did baby steps to contribute to some of these agents, in particular the hotel collector. And at the end, what we produced is some recommendations on how to fine tune the config to give to our customers and support them. But still, I think the higher produced latency was the biggest pain point for us, and something I should have addressed back in time.
Fair enough. Yeah. Last. You can take us out, Cyril. Finish the podcast on with what should I have asked you? What would you have done differently?
I don't think there's anything you should have asked me, but I think on Marco's last point, I will do like Matt and say, why don't you use Cursor to fix that?
You mean Claude?
I mean, yeah, Claude. Okay.
Yeah, from time travel. And I do feel like we are in the future sometimes with these new AI technologies. So it is quite exciting. But unfortunately, time does still matter and we have run out of it. But thank you so much. That was really great, kind of deep technical chat. I learned a lot. I've got a lot of notes. Marco, I've got a lot of questions for later. Last time we were in Montreal, we did a thing in Montreal, Cyril, Marco and I, and they said, do you want to come for a cycle around the city and just see it? And I was like, oh yeah, that sounds nice. Marco said, yeah, normally I do like 1.5 kilometers, something like this. So I was like, oh, okay, that sounds good. But he meant up. This was a 53 kilometer bike ride around the city.
Just a small bike ride.
Yeah. So, but yeah, very and fast, obviously. But no, So if I went back in time,
It didn't look fast.
well, thank you. If I went back in time, I'd probably just say, "I'm all right, thanks, Marco.
I'll go to
I'll
the
just
pub instead."
stay here." Yeah.
Well, be ready to bike again in Amsterdam in November.
Oh yeah, but luckily Amsterdam's nice and flat.
Yeah, everything is flat there.
Okay. Well, this is also time to say goodbye. Thank you so much to our guests, Cyril, Ryan, Marco. Fantastic stuff. Tom, see you next time.
Yeah, thank you, Matt.
Grafana's Big Tent, innit?